Welcome back, boys and bugs. We're going to find some values of graphs today and talk about how to identify roots. And I know what you're thinking, Mr. Barton, why do I care? Why would I ever need to be able to read a graph? Clearly, nobody in the government can read graphs. Why should I learn to read a graph? To which I just have one picture to show you. I think that makes it pretty clear why graphs are so important. All right, so let's start off with talk about how do we find a specific value on a graph. This is basically how do I read graphs, how do I interpret information off graphs. So let's hop right into it. Don't forget to hit the notification bell at the bottom. Let me know what you think in the comments below. Joke's on you, I turned them off. All right, to find a specific value for a function, let's say we'll call it f of x. What you want to do is move horizontally to whatever the value of x is. And this x is talking about whatever number you see inside the function. And look at what is the height of the graph when you are at that value of x. Okay. This is just a pretty graph for looking at. So let's do a couple of examples, shall we? We want to find some values on this wonderful linear graph, and they're written out here. So these numbers that are inside the functions are telling us what x values we want to go look at. And I'm asking you, when you get to this x value, what is the y value there? How high up or far down is the graph at that x location? So if we start with f of negative 2, you want to go to negative 2 on the x-axis and then figure out how high up is the graph right there. Or another way we could say it is, what's the ordered pair when the x is negative 2? What's the y value of the graph there? So we just go over to the y-axis, we look, and it's 2. So we'd say f of negative 2 is 2, because the height of the graph is 2 at negative 2 on the x-axis. For f of 0, we don't have to go anywhere. We're already at 0, so we just see how high up the graph is. There's 2. This is half of that, so this is 1. So f of 0 equals 1. At f equals 1, we go over here. Oh, this one's kind of hard to read, isn't it? So when you are reading graphs, I want you to go ahead and just round or assume the nicest number. So here's 1. This was 1. Right there's 1 box. 1 is 2 boxes, so this must be a half. I'm not going to pull something sneaky on you and go, well, technically, kids, this was actually 0.48. You should have busted out your pixel measuring tool to figure out exact... No. We're looking at graphs, so you just guess the closest number you possibly can. All right. Last one, f of 6. We go horizontally to 6. Then we check the height of the graph at that spot. So we're looking right there. We are at 6, negative 2. So the output or the value of our graph at 6 is negative 2. Pretty straightforward, I hope. All right. The next thing we want to talk about today is finding roots of a graph. So let me just give you a heads up, because this is going to be something that you're going to do probably for the rest of your life, unless you drop out of school and become a hairstylist, in which case you still need to know graphs to line up that fade just right. For roots, there's a bunch of different names that mathematicians use for them. We have zeros, x-intercepts, and sometimes they're called solutions, or obviously roots. So if you hear any of those 4 words, we're talking about the same thing. We want to know, where does our graph touch the x-axis? So there's a couple of different ways you can write out a root. For right now, I want you to just tell me, where is the root at on the x-axis? So you could say, for example, this one, we could say x equals 0 and x equals negative 4. You could give me the full ordered pair. These are more like x-intercepts of 0, 0, and 0, negative 4. Oh, I'm sorry. Let's back that up. I'm slightly dyslexic. No, I'm not. That's made up. I shouldn't appropriate other people's disabilities for my political gain. This is -4, 0. So one reason these are called zeros is you'll notice the y value for these is always 0. That's where that name comes from. So we're just looking, where does the graph touch the x-axis? And for right now, we're really just worried about the x value of those points because that's the interesting part. The y's are 0 by definition. All right, let's look at a couple of quick examples, and then we'll send you on your way so you can get your homework done. I just did this one. Obviously, the root is right there and right there. We are at -4 and at 0. Here, we follow our graph, find where it touches the x-axis. Make sure you know where the x-axis is. Sometimes it moves around. Sometimes it's down there, sometimes it's up there. Make sure you're looking at the bold line. So right here, here's -2, here's 0. That looks like it's halfway in the middle to me, so I'm going to say this is x equals 1. And then this one, here's my x-axis. This thing doesn't touch the x-axis ever. It doesn't reach, right? It doesn't go down far enough. So this one has no roots, which is possible. All right. So there's how we find values off of graphs and how we find roots visually by looking at the graph. Hopefully that's pretty straightforward for you. Let me know if you need any help.